All right, guys, we're going to be doing Newton's second law of motion. The area that is orange is the section of notes that we'll be dealing with today. So let's get going.
The second law is all about a simple formulation to get the forces, multiply mass and acceleration. If that's too much to say, there is an easy way. Try this abbreviation for this simple formulation.
F equals M-A, F equals M-A, F equals M-A. Now that's the abbreviation. F equals M-A, F equals M-A, F equals M-A.
Force equals mass times acceleration. Force equals mass times acceleration. Acceleration. Force equals mass times acceleration. Acceleration. F equals ma. F equals ma. F equals ma. F equals ma.
Alrighty, so the first box says F equals, well, according to that song, F equals MA. Remember, you've seen this formula before when we did the triangle math practice. In case you didn't do that activity, we looked at the four formulas that you guys would see on your reference chart for your STAR test. So M stands for mass, and A stands for acceleration. Okay, remember in science, we don't measure things in weight, we measure things with mass. So if F stands for net force, we must be dealing with unbalanced forces, because in order for F equals ma to work, we're going to be possibly accelerating objects, experimenting with different forces. So the type of force that we're dealing with is an unbalanced force, because unbalanced forces cause changes in motion. And you're going to see changes in motion as we change the force amount on certain objects and the masses. Next box, M stands for mass and A stands for acceleration. I showed you that a second ago. Your next box states that acceleration is produced when an unbalanced force acts on a mass. So we're going to look at this video of football that's going to explain how Newton's second law plays a role in America's favorite sport. Unfortunately not mine, but hey, people love them some football. And I have to admit, sometimes it's kind of fun to watch. I like it live though. Anyway, you're going to see how Newton's second law plays a role in football.
To be an NFL kicker takes more than just nerves of steel and a strong leg. It also requires help from one of the key laws of physics.
It's easy to say, well, I just kicked the ball. Well, let's delve into it. Let's look at the specifics. What actually happens when you kick the ball, and why does the ball go where you ask it to go? And it is Newton's second law of motion.
The second law is one of three laws described in 1687 by Sir Isaac Newton, who used them to describe how and why objects move.
So the second law says if you have an object with a mass that is accelerating, and acceleration means a change in velocity, that is equal to the amount of force applied to the object. The way we say it with words is F is equal ma.
This also means that in order for an object like a football to accelerate, a force must be applied. To illustrate Newton's second law in kicking, we asked Morten Andersen, NFL's all-time scoring leader, to perform his craft in front of a high-speed phantom camera. The entire procedure unfolds in less than a second and a half, from snap to hold to kick.
It's all about training and rehearsing and doing something over and over and over again.
To reduce the chance of a block, NFL kickers take just 3 steps to the ball. The final step is with the plant foot, which provides the stable platform for the kick.
I call it the moment of truth, and the moment of truth is basically when your plant foot hits the ground next to the ball. You're either in the right position or the wrong position.
The kick itself involves the entire leg building the force necessary to launch the football.
It's a hammer, and you're swinging the hammer, and you're trusting it, and it's going to be, it's going to be impacting the ball with great velocity.
An NFL kicker's foot is in contact with the ball for just 8/1000ths of a second, and in that time, his foot applies up to a ton of force to the ball. This quick, violent strike is a perfect example of what's known in physics as an impulse.
Impulse is an important concept because there is a finite time over which the foot is in contact with the ball, and during that time there's a force applied to the football.
An impulse is equal to the force multiplied by the time the force is applied, represented by delta T. If force is graphed versus time, it's possible to see how a larger force or a longer time for the force supplies a bigger impulse.
Since impulse is really just the change in momentum, and since the ball doesn't change its mass, we're really just talking about the change in the speed. The bigger the impulse, the bigger the change in speed, which means the faster the ball is moving after it leaves the kicker's foot.
Ironically, Anderson says the distance of the field goal doesn't change his approach to the kick itself.
Mentally, you want to look at a 50-plus yarder, like a 40-some yarder, with some room to spare. I think that's a good way to kind of fool yourself into thinking it's a shorter kick.
Whether the kick is short or long, Newton's second law explains what an NFL kicker must do to send a football through the uprights.
So let's look at this. So the amount of force in addition to the mass affects how the object would accelerate. Now I know this says with your elbow partner, but let's ignore that. We don't need to worry about that. Okay, we're looking at these 2 cars. The cars obviously have equal masses, but they're being pushed with different amounts of force. Okay, this car is being pushed with 6 newtons, while this one is being pushed with 18. Which car is going to accelerate more? That means have a greater speed change. Remember, acceleration is speeding up, slowing down, stopping, or changing directions. So which one is going to have greater acceleration? Well, if you said the orange one, you're absolutely right. Both cars have the exact same mass, same person driving. You're applying more force, and so it's going to be able to speed up at a greater rate than the force that's only giving off 6 newtons. Okay, so let's go to the next box, which says that acceleration is produced when an unbalanced force acts on a mass. So remember, acceleration is speeding up, slowing down, stopping, or changing directions. And so that can only happen when you have an unbalanced force, which is something that changes the motion of an object, acts on a mass. Acceleration is a change in the motion of an object. Acceleration is caused by unbalanced forces. So remember, acceleration can be speeding up, slowing down, stopping, or changing directions. So those 4 things change the motion of an object, and the basic definition of acceleration is a change in the motion of an object. Okay, the greater the force applied to an object, the greater the object's acceleration. It's just like our cars again. Okay, the greater force, the greater the acceleration. The car that has 18 newtons of force is going to accelerate way better than the car that has 6 newtons. It's not going to go very fast. So the greater the force applied, to an object, the greater the object's acceleration. All right, the greater the mass of an object, the slower the acceleration of the object. So it's kind of like this. If you have me, that's me, Mrs. Jones, okay? sitting in a chair, and a 5-year-old tries to push me. 5-year-old. Okay. She's heavy. Okay. She tried to roll me in that chair. She might have a harder time. My mass is so much greater. Then on top of that, you've got me in a rolling chair. So the 5-year-old is going to have a hard time applying enough force to push me in the chair. Not going to work very well. But then if you remove me from the chair, the mass becomes so much lighter that the 5-year-old should be able to apply the same force they tried with me, and the chair should go in motion. Y'all like my win? That's my win right there. Okay. But it can now accelerate at a much greater rate, and the motion can definitely change because the mass has changed. So this is going to work. The very last thing is the equation is F equals ma, and this is the triangle. You've already been shown this, and it's on our brain dump. You just always need to remember that the F goes on top, and then you cover up what you're looking for, and it tells you what to do mathematically. So if the letters are on top of each other, you divide. If they're side by side, you multiply. And that's going to be Newton's second law.